Hello, uh, this is Digital Electronics Lab, and today we will see some tools which we are going to use when we perform the experiments in breadboard. Okay, so far we have done so many experiments in trainer kit. So trainer kit is basically a device by which we can easily perform the experiments. Okay, but when you design a particular circuit for a specific purpose, the ready-made kit will not be available with you. Then you need to build the whole circuit in breadboard. Okay, so that's why this skill to develop a circuit in breadboard became very important. Okay, because for testing purpose you have no option. You need to go with the breadboard when you go for testing purpose for a particular IC. Okay, or particular circuit. So today we will see some tools, some equipments what we are going to use when we use the breadboard for digital electronics lab. Okay, so here you can see this kit is very important to for digital electronics lab when you are performing the whole experiment in breadboard. Okay, then you have multimeters, breadboard. There is an IC tester is also there. In IC tester we can test a IC because by seeing physically it is not it is impossible to identify the whether the IC is working properly or not. Okay, so that's why we use a IC tester to see whether this IC is working properly or not. Okay, because if there is any fault in a particular IC, then the whole circuit will become faulty and it will not work properly. Okay, and physically by seeing you cannot identify which IC is not working. Okay, so it is very important to test the IC before you are going to use the IC. So first thing first is IC tester. You need to know how the IC tester is operated. Okay, then you need to know about the board where you can perform the whole experiment. You need to know all the details about the ICs. Okay, say suppose in case of logic gate IC we have 14 pins are there. Okay, it is very important to identify particular pin because for a particular IC you need to give the power supply and VCC and the ground terminal ground you need to connect. So that's why it is very important to identify which terminal is for ground and which terminal is for plus VCC. I will show it everything in detail. Okay, and then there is a multimeter. Okay, and it is also very useful tool to measure the voltage or current, whatever it is. So we will learn about multimeter also. Okay, but before that let me give a brief idea about IC. Okay, so in the previous day I have told that there are certain numbers. Suppose I have taken an IC and it is written 7486, that means it is an XOR gate IC. Okay, by seeing the number which is written on the IC you can easily identify for a particular IC. Okay, so let's say suppose you develop a circuit, you want to build a circuit which contain two say suppose AND gate and XOR gate or NOT gate or XOR gate. So you have easily identified the XOR gate IC by using the number. Okay, and for a particular IC, if it is a XOR gate IC, all the gates will be XOR. Okay, so if you require two logic gates to build a circuit, you will require two IC. So it's 7404, that means it's NOT gate IC. So we have XOR gate IC and NOT gate IC. Now we can build the circuit. Okay, so this is the first step to check the IC whether it is working properly or not. You need to find out the notch. I will show you by zooming what is notch. So then you need to identify the notch, okay, so that you can easily calculate the pin numbers. By seeing the IC notch, you can easily identify in which way you need to connect the IC, okay, in breadboard. So you need to have a basic understanding about breadboard also. I will give a idea about that. Then you place the IC, then you give the VCC and power supply. Here power supply and ground terminal. You will connect it with the help of this kit, and then according to your circuit, whatever you have built or draw in your copy, according to that you need to build the whole circuit in this breadboard. And to build the circuit, you can use this kind of wire to connect the terminals, okay. Let's zoom in and see the detail on IC, okay. Just wait for a while. So this is basically IC tester. This kit is basically IC tester. These are the ICs. Sorry, these are the ICs. These are few ICs are there, and this is your IC tester. Okay, this is your IC tester, and here you can easily test your IC. I will not give power to this equipments, okay, because the power supply is on table, and I will give power supply later on. But let me give me a demo. So you have find out this IC, or you have find out this IC, okay. So you have find out this IC and you want to check the IC. So what you need to do, you need to firstly you need to find out the notch of that IC, okay. And how you can find out, if you can see this IC, you can see there will be a portion which is it is not showing clearly. So this portion is cut. Yes, there is a cut in the IC, and this is notch, okay. And if it is notch, then you need to connect the pin from this side. So this is pin number 1. If we placed it in breadboard, you can see easily. So I have placed it on breadboard. Now you can see this is the number 7486. 7486. So this is XOR gate IC, okay. And we placed this IC like this manner, so that both the pins are in separate terminal, okay. I'll give idea about breadboard later, but before that please see. So this is notch, you can see here clearly, this is called notch, and from this side of notch you will start calculating the pin numbers. So this is pin number 1, 2, 3, 4, 5, 6, 7. So this is pin number 7, and you need to ground it, okay. So pin number 7 is ground. This is pin number 7. Now pin number 7 to pin number 8, 9, 10, 11, 12, 13, 14. This is pin number 14, and you need to connect this terminal to the VCC. That means you need to give a power supply to this terminal, okay. So this is ground, pin number 7, and pin number 14 is for power supply, okay. So this is how you can identify the pin number and notch. And when you do that, after identifying the pin number, you need to place the IC here. Here you need to place the IC like this way, and after placing the IC, you need to lock the pin with this knob. Now we have locked the pin, and now you need to give the IC number. It is 7404 for NOT gate IC. This is, so you need to give 7404 and then test. Easy, it's so easy. If you press test here, it will show error if the IC is burned out or if it is not working properly, and if it is okay, it will show that this IC is okay. Okay, so now you can open the IC from this IC tester, and you can place it to the breadboard. Let me place it. So, and in case in breadboard, you need to place the IC in between these two terminal. So just give me 1 minute, I'll give a brief that what is breadboard. So this is basically a breadboard. This is to separate breadboard. You can connect both the breadboard if the circuit is large, or you can separate the breadboard and use separately if the circuit is small. So you can place the breadboard over here inside the kit. Now let's see how the connections are there in case of breadboard. Just hold on for 1 minute. Okay, now you can easily see. So this is breadboard. Okay, this is breadboard, and you can see here there are so many terminals are there, so many holes are there inside this breadboard. Now here in these terminals, these terminals are shorted. Okay, if you take 5 division, 1 2 3 4 5, these 5 terminal are connected internally, only this line. So there is no connection in between this line and this line, but there is a connection between this line and this line, this line, this line. Okay, so this is how this line is connected, 5. And for this kind of terminals, this terminal are connected like this way. So no connection between this point and this point. There is no connection between this point and this point, but there is a connection in between this point and this point, and this point and this point, this point and this point. So this is how they are connected in this way. In this way they are connected. So if you want to, and same case for this side also, this is connected and this is connected. Okay, so now you need to place the IC like this way in the middle of the breadboard, because you don't want to short the 2 pins. Okay, that means if we put the IC in this way, this 2 pin will not get shorted. Okay, because there is a division. There is a division here. So if we place the IC in this way, this 2 pin will not get shorted. Okay, so now you place the IC, and then you need to connect the whole the ICs with connecting wire, so that you can complete your circuit. For example, if I want to connect these 2 IC, then we will connect, say suppose pin number 1 and pin number 1 I will connect. So this is pin number 1 for this IC, and this is pin number 1 for this IC. So you need to connect it like this way. Now these 2 ICs are connected with pin number 1 and pin number 1. So this is how we can connect the ICs. Okay, and now let's take an brief example of whole the board, so that you can have a clear understanding about the VCC power supply, how we need to give that, and then how we will give input and how we will observe the output. You can have a basic understanding. Okay, so this is the board where you can perform the experiment. Here you can see that there are some certain knobs are there. This is for CMOS and TTL. If your logic is in CMOS, then you need to place it in CMOS, otherwise it will be TTL logic. Okay, these two knobs are for power supply. Okay, it will give DC power supply, and it is variable. You can see here we can vary the knob and you can easily give the power supply. This is for positive DC power supply, and this is for negative DC power supply. Okay, so suppose if you want a positive 12 volt, you can easily vary the knob and measure the output voltage with the help of a multimeter, and you can fix it in 12 volt, which is positive 12 volt. But in case of negative 12 volt, you need to use this knob and these terminals. Okay, so positive DC voltage, negative DC voltage. Then you have plus 5 volt, ground, and minus 5 volt. Okay, so this is plus 5 volt, this is ground, and this is minus 5 volt. So as I have already told that in case of IC you need to give a positive plus 5 volt and ground. So pin number 7 is ground, so you need to connect from this terminal to this terminal. From this terminal to this terminal you need to connect the ground. And then in case of pin number 14 you need to give the plus VCC, that is plus 5 volt. So you need to connect this terminal to pin number 14. This terminal to pin number 14 we can provide plus 5 volt or plus VCC. Okay, so this is how we can easily give the plus 5 volt and ground, okay, from this kit. Then we have a pulsar, that is we can provide pulses. Okay, there are two pulses, there is a provision of giving two pulses from this kit. So if we press it, it will be positive pulse. If we want to give negative pulse, you can easily give that with the help of this knob. Here also the same case is happening, it is positive pulse, it is negative pulse. Okay, and this pulse is not required rapidly, it will be required in case of counter or registers, which is the last topic, so we will discuss it later. Then we have some BCD display board over here, which is also not so important now, so I will discuss it later. Then we have display logic display probe, so this is also not so important now, we will discuss it later. Now here is function generator. Okay, so this is function generator. Function generator means if you want a specific voltage or specific wave shape of signal or specific frequency signal, you can easily control all these parameters, and you can supply the wave or voltage to a particular IC. So let's say suppose you have built a IC which required a plus 5 volt, and the wave shape will be triangle and its frequency will be 10 kilohertz. Okay, so our requirement is 10 kilohertz plus 5 volt triangle wave signal. Okay, so there are three parameters plus 5 volt. So this is the knob of amplitude, where you can fix the plus 5 volt. Amplitude means the peak value of sinusoidal wave, and we need to fix it in 5. So with the help of this knob we can easily fix that voltage of that signal. Now we require triangle wave, so we need to place it in triangle. You can see here it is already given, it's so easy. Triangle is given over here, so from here you can easily give the triangle. Okay, now it is we require 10 kilohertz signal, so we need to place it in 10 kilohertz. Okay, and say suppose you want 15 kilohertz signal, so this is 10 kilohertz is the range of 10 kilohertz. Then you need to place it in 100 kilohertz, and you need to vary with the help of this knob. You can vary the frequency with the help of this knob, and you can easily observe the frequency in CRO, and you can set as per your requirement. And these two terminals are ground and output. From here you will get the output, and this terminal you can connect it with the CRO so that you can easily observe the output. Okay, and now came to the middle portion of the kit. So here you can see this place is for breadboard. We can easily place the breadboard here. You can place a single breadboard also, or you can connect both the breadboard if your circuit is large, and you can place it over here. Okay, and from these terminals you can give your inputs. From this terminal you can give your inputs, and here you can observe the output. Okay, so say suppose you are using this NOT gate and you want to verify the NOT gate IC with the help of truth table. So what you need to do, let's open this IC because we are using only NOT gate. So let's remove the IC. So first you need to do is to place the IC in the breadboard. Then you need to give the power supply, that is this pin number 7. So plus 5 volt will be given over here. It is pin number 14. So sorry, pin number 7 we need to connect the ground. Pin number 14 you need to connect the plus 5 volt. Okay, and then from input terminal you will give to pin number 1, and pin number 2 is output for NOT gate. You will connect over here. I will show the internal circuit diagram also about all the ICs, but I will show it in later. Okay, before you grab the whole idea about what we are going to do when we want to build or want to design a circuit, then we will see the internal circuit diagram. So in case of NOT gate, pin number 1 is input, pin number 2 is output. So this is pin number 1, so we will connect it over here, and from pin number 2 we will take the output and we will connect over here. Okay, so when you will give 1 from this terminal, it will be 0 as it is NOT gate, and when we will give 0 over here, we will get glowing LED, that is 1. Okay, so this is how we can verify a single IC, or you can design a whole circuit and we can perform the experiments. We will design the whole circuit on later classes using 2 or 3 ICs, but today I will not design that because it will consume more and more time, and we haven't so much time because we have only one class today. And another important thing is multimeter. This is basically multimeter, which is very useful. We can easily determine what is the voltage. You can easily measure with the help of this multimeter. Okay, here you can see this is the portion where you can measure the resistance. It shows ohm. Here it is for DC voltage. This portion is for AC voltage. This is for current, DC current, and this range is for AC current. Okay, we can easily test the diode also with the help of this multimeter. Here you can see there is a symbol of diode. So if you want to test a diode, whether the diode is working or not, you need to place the knob over here, and then you can easily verify the diode. Another thing is that you need to connect the probes, and this is red, that means you need to place it over here. This is black, that means you need to place it over here in common terminal, that is ground terminal. Okay, and these are the knobs from where you can easily measure the voltage. Okay, so this is another important tool what we are going to use when we will build the circuits. That's what it is. So that's it for today. Okay, thank you. We'll discuss rest of the portion on the next class.